Hello, this is Mr. Miller, and in this video we're going to show how we can check if complex numbers are a solution to a quadratic equation. All right, it's going to be fun. First, before we do the examples, I want to remind you about the number I that we've introduced. So you got to keep an open mind about it. It's a number with a very special property that when you square it, you get -1. All right, so it's kind of a different number. It can't be positive, it can't be negative, it can't be zero. I is different. But when we introduce I, we don't just introduce one number, we introduce a lot of other numbers with it. For instance, we might want to know what I plus I is. What do you get when you add I to itself? Well, you get 2I, which is a different number. You might want to know, well, what do you get when you add 5 to I? Or what if we multiply I by 3 and add 7 to it? All of these are different numbers we get. So by introducing this one number I, we actually introduced a lot of numbers. I just want to take a second here for some important definitions. Real numbers are the numbers we're used to, the numbers on the number line. That include whole numbers like 7, negative numbers like -2, decimals, square roots that go on forever, fractions, numbers like pi. All these numbers fit on the number line. A purely imaginary number is a number that is a multiple of I. Like when you take a real number, for instance 19, and multiply it by I. 19I or pi times I or -7/3 I, these are all examples of pure imaginary numbers, a multiple of I, something times I. A complex number is a number we get when we take a real number like 9 and add to it or subtract a purely imaginary number like 4I. And that's called a complex number, a number that has a real part plus a real number times I. Now, complex numbers include the real numbers because maybe b is 0. If b is 0, then we just have a real number. It also includes the imaginary numbers because if a were 0, we just have, like, for instance, 2I. That's a purely imaginary number and it fits in the set of complex numbers. So here we go. The outer circle is the complex numbers. It includes the real numbers we're familiar with and also the purely imaginary numbers. All right, so you'll be hearing these names a lot. All right, well, for this video, the main point is we want to show that a complex number works in a quadratic equation. For instance, this equation, if we tried using the quadratic formula, we'd find out that it has no real solutions, but it has complex solutions. All right, so we're going to check that 4 plus 9I is a solution to this equation. That means we're going to put the quantity 4 plus 9I into the equations for x, and we're going to use a little of the arithmetic we learned to show that this is true. So the first thing we have to do is square 4 plus 9I. So I'm going to work that out over here. We got to do 4 plus 9I times itself. And I'm going to use FOIL to do that. When we multiply the first, 4 times 4 is 16. We multiply the outer, 4 times 9I is 36I. And when we multiply the inner, we get 9I times 4, which is another 36I. And when we multiply the last, 9I times 9I gives me 81I squared. Remember that I squared is equal to -1. So we're going to put -1 in there. So we get 16. These two together make 72I. 81 times -1 is -81. And then altogether, 16 minus 81, this is -65 plus 72I. This is kind of really the pain of the whole thing of what we're doing, is just kind of multiplying out something like this. But I want you to be able to do it. So this first thing is -65 plus 72I. Now, we're ready to move on. Minus 8 times 4 is minus 32. Minus 8 times 9i is minus 72i. Plus 97, hopefully, will equal 0. Well, minus 65 minus 32 is minus 97. We have a 72i and a minus 72i. So when I do a little simplification, I get minus 97 plus 97 equals 0, or 0 equals 0, which is true. Turns out that this number, this complex number, does work and make this equation true. All right, so that's a lot, but we're just doing some arithmetic with complex numbers like we've already learned how to do, and showing that when we substitute in the equation, it makes it true. All right, now, after we do that a couple times, we're going to go ahead and use our calculator to check these things. Our calculator has an I button. It's located right here on the calculator. When you press this button, it rotates in between pi, the number e, which we'll talk about later in this course, and the number I. So if you want I, you got to press it a couple times, and you'll see it'll appear on the screen. All right, so basically on our calculator, we're just going to carefully put this in for x. We're going to do 7 minus 2i squared minus 14 times 7 minus 2i plus 53. And it turns out, if you enter this into the calculator, it's going to say equals 0. So if this is true. 7 minus 2i actually does work in this equation. So the calculator saves us a lot of work by being able to do arithmetic with I. All right, last thing I want to mention is, probably comes as no surprise, that Desmos also does this. If you click this right here, the wrench, which is the settings, and if you go down, there's something called complex mode, which will, if you turn this on right here, enable Desmos to do arithmetic with complex numbers. And so we can go to the command line, and I just entered 7 minus 2i in for x, and just to see what the equation would equal. And it turns out that it equals 0, just like we found on our calculator. So Desmos, you can use Desmos also to check if a complex number is a solution to an equation. Sometimes something a little quirky happens here. One time I was doing this, I got an answer like 1 times 10 to the negative 16 plus 0i. If it does that, you got to realize this is a number that's very close to 0. Times 10 to the negative 16 means there's 16 zeros after the decimal point, and then a 1. So, all right, we got to realize that this is pretty much just 0. That happened to me once, so other than that, complex numbers work really well with Desmos. Okay, good luck.